Welcome to RP Guru Tech Talk, your one-stop YouTube channel for your everyday tech questions. Time series analysis involves analyzing data that is collected over time. It is widely used in various fields such as finance, weather forecasting, and healthcare. In this video, we will explore the techniques and models used in time series analysis, and how they can be applied in real-world scenarios. Section 1. Time series analysis techniques. Time series decomposition. Breaking down a time series into its constituent parts, such as trend, seasonality, and noise, can help us better understand the underlying patterns and relationships within the data. Trend represents the long-term direction of the data. Seasonality refers to recurring patterns over a fixed period of time. And noise represents the random fluctuations in the data that cannot be explained by the trend or seasonality. By separating these components, we can make more accurate predictions and identify anomalies in the data. Autoregression. Autoregression is a statistical model that uses past observations to predict future observations. In autoregression, the prediction for the next value in the series is a linear function of past observations. The order of the autoregression, denoted as ARP, represents the number of past observations used in the prediction. For example, AR1 uses only the most recent observation to make the prediction, while AR2 uses the two most recent observations. Moving average. Moving average is a time series model that uses the average of past observations to predict future observations. In moving average, the prediction for the next value in the series is a linear combination of the most recent observations. The order of the moving average, denoted as MAQ, represents the number of past observations used in the prediction. For example, MA1 uses only the most recent observation to make the prediction, while MA2 uses the two most recent observations. Exponential smoothing. Exponential smoothing is a technique that assigns exponentially decreasing weights to older observations in a time series. In exponential smoothing, the prediction for the next value in the series is a weighted average of past observations, where the weights decrease exponentially as the observations get older. Exponential smoothing is particularly useful when the time series contains a trend or seasonality, as it can capture these patterns and make more accurate predictions. Section 2. Time series analysis models. ARIMA, Autoregressive Integrated Moving Average. ARIMA is a popular model used for forecasting time series data. ARIMA combines autoregression, AR, and moving average, MA, models, and includes differencing to account for non-stationary data. The order of the ARIMA model is denoted as ARIMA, P, D, Q, where P is the order of the autoregression, D is the degree of differencing, and Q is the order of the moving average. SARIMA, Seasonal ARIMA. SARIMA is an extension of ARIMA that includes seasonality in the model. SARIMA combines autoregression, AR, moving average, MA, and seasonal components to account for periodic patterns in the data. The order of the SARIMA model is denoted as SARIMA, P, D, Q, P, D, Q, M, where P, D, Q represents the non-seasonal components, P, D, Q represents the seasonal components, and M represents the period of the seasonality. Profit. Profit is a model developed by Facebook that uses a combination of trend, seasonality, and holiday effects to forecast time series data. Profit is designed to handle time series data with seasonality, and can also incorporate external factors such as holidays and events that may impact the data. Profit is particularly useful for forecasting data with long-term trends and multiple seasonality patterns. Section 3. Applications of time series analysis. Forecasting. Time series analysis is commonly used for forecasting future trends and values in a time series. Forecasting can help businesses make informed decisions about future investments, product demand, and resource allocation. Forecasting can also be used for financial planning, weather forecasting, and demand forecasting in various industries. Anomaly detection. Time series analysis can also be used for anomaly detection, where the goal is to identify data points that deviate significantly from the expected pattern. Anomalies can indicate errors in data collection or signal important events such as equipment failure, cyber attacks, or market shifts. Anomaly detection can be used in industries such as finance, healthcare, and manufacturing to improve quality control and risk management.
Time series classification.
Time series analysis can also be used for classification tasks, where the goal is to assign a label to each time series data point. Time series classification can be used in industries such as healthcare, where it can help diagnose diseases based on patterns in patient data, or in finance, where it can help classify financial transactions as fraudulent or legitimate. Section 4. Challenges in time series analysis.
Non-stationarity.
Non-stationarity refers to time series data that exhibit changing statistical properties over time, such as trends, seasonality, and noise. Non-stationarity can make it difficult to build accurate models, as the relationships between the data may change over time. To address non-stationarity, techniques such as differencing and detrending can be used to make the data stationary. Overfitting. Overfitting refers to a situation where a model is too complex and fits the training data too closely, resulting in poor generalization to new data. Overfitting can occur in time series analysis when a model includes too many past observations or when the model is too flexible. To address overfitting, techniques such as regularization and model selection can be used to find the optimal balance between model complexity and performance. Missing data. Missing data is a common problem in time series analysis, as data collection may be interrupted or incomplete. Missing data can lead to biased estimates and reduce the accuracy of the models. To address missing data, techniques such as imputation and interpolation can be used to fill in the missing values. Conclusion. Time series analysis is a powerful tool that can help us make better predictions, detect anomalies, and classify time series data. By understanding the techniques and models used in time series analysis, we can unlock valuable insights from time series data and make more informed decisions in a variety of industries.